Jai Hind, dear students. I am Dr. Preeti Mittal, and today we are going to continue with our chapter Chemical Reactions and Equations. In the previous video, we have discussed about displacement and double displacement reactions and performed some experiments also for the same. Now let's discuss oxidation and reduction. This is my personal favorite topic. So let's start with that. If we take copper in a china dish and start heating it, we'll find that the brown colored copper will turn into black because of formation of copper oxide. So if we create a system like this, then we'll find that copper is getting converted to copper oxide on reaction with oxygen present in the atmosphere. So let's look at the reaction. What happens? Copper combines with oxygen in the atmosphere to form copper oxide. This copper has brown color and the copper oxide formed is black in color. Just remember that the color of copper oxide is black. It's asked as a question in your NCERT book as well. So this is an example that how oxidation of copper is taking place. But when we pass hydrogen gas through this black colored copper oxide, we find that the copper again comes back. Means again we find the brown colored copper because of the reaction taking place is like this. So if we pass hydrogen gas through this solution, through this powder, not solution, sorry. If we pass hydrogen gas through this copper oxide powder, then we find that the oxygen from the copper is taken away and that is getting converted to copper again and with the formation of water. Now, in this reaction, there is redox reaction occurring. Apart from that, what we have discussed earlier, let's just recap that hydrogen is more reactive than copper, and so this is an example of displacement reaction also. So the reaction that I have written, this is an example of displacement reaction also, because a higher reactive element like hydrogen is displacing oxygen from a lower reactive element, that is copper. Okay. Now, in this reaction, there is removal of oxygen from copper oxide. So, there is reduction of copper oxide. And there is addition of oxygen to hydrogen. So, there is oxidation of hydrogen. There is oxidation of hydrogen. So, whenever there is addition of oxygen, that is known as oxidation reaction. And whenever there is removal of oxygen, that is known as reduction reaction. Okay. So, remember that whenever there is addition of oxygen, that is oxidation reaction. And whenever there is removal of oxygen, that is a reduction reaction. Now, the question that is asked in your exams is, which of the following is getting reduced? So, which of the following is getting reduced? The options are copper oxide, copper, hydrogen and H2O, water. Which one of them is getting reduced? So, copper oxide is undergoing reduction. Copper is not getting reduced. It's copper oxide that is losing the oxygen. So there is reduction of copper oxide. Remember that. It's very important for exams. Now, when there is reduction of copper oxide, which substance in the reaction is helping copper oxide to get reduced? That is hydrogen. So hydrogen is known as reducing agent. That is known as reducing agent. A substance that carries out the reduction of some other substance, that will be known as reducing agent. Right? Just like a travel agent. The travel agent books tickets for you, but doesn't travels by itself. So the one that is helping copper oxide to undergo reduction, that is hydrogen, because hydrogen is taking oxygen from that. Na? So the agent which is helping reduction of copper oxide is hydrogen, and so it is known as a reducing agent. Similarly, when I'm saying that hydrogen is undergoing oxidation, what is helping hydrogen to undergo oxidation? That is copper oxide. So, copper oxide will be known as oxidizing agent. Copper oxide will be known as oxidizing agent. To remember one thing, just remember by that whichever is undergoing reduction, that is itself is an oxidizing agent, and the one that is undergoing oxidation, that is itself it's a reducing agent. So whenever there is any such reaction, when you have to identify which one is getting oxidized, which one is getting reduced, which one is oxidizing agent and which one is reducing agent, just simply work out one thing, that whichever is getting reduced, just you have to find one thing. For example, I'll tell you one more example. For example, we have iron that combines with copper sulfate solution and forms FeSO4 plus copper. Okay, and in this reaction I'm asked then which one is getting oxidized, which substance is getting reduced, which is the oxidizing agent and which is a reducing agent. So you can easily work it out. Since copper oxide was having oxygen, but now copper is formed that is not having the oxygen, that is removal of oxygen is there. So removal of oxygen is reduction. So there is reduction of copper sulfate. Okay. Now, whichever is getting reduced, the other one is always having oxidation. Okay. If this is undergoing reduction, the other one is definitely undergoing oxidation. So, can I raise the upper reaction? So, when there is reduction of copper sulfate, definitely the other product, the other reactant was iron, and so there is oxidation of iron to form ferrous sulfate. Which one substance is getting oxidized? So that is iron, that is undergoing oxidation to form ferrous sulfate. So which one is getting oxidized? There is oxidation of iron. Okay. So if just identify one of them, the other one will come automatically. One is getting reduced, so it's undergoing reduction. The other one is definitely undergoing oxidation. The one that is undergoing oxidation, that is itself a reducing agent. So, copper sulfate is undergoing reduction. What has helped copper sulfate to undergo reduction? Who has taken oxygen from it? Iron. So, iron is a reducing agent. Now here, iron is getting oxidation. Iron is undergoing oxidation. So, which substance is helping iron to undergo oxidation? Which substance, which reactant is giving oxygen to iron? That is copper sulfate. So, copper sulfate is oxidizing agent. Okay. Just identify one of them, उसका opposite होता जाएगा. For example, copper sulfate is undergoing reduction, तो दूसरे वाले का oxidation हो रहा है. जिसका oxidation हो रहा है वो खुद क्या है? Reducing agent. And जिसका reduction हो रहा है वो खुद क्या है? Oxidizing agent. Okay. So by that reverse things, you can identify that. Okay. I hope that is clear to you all. Okay. Now, this reaction is an example of redox reaction when oxidation and reduction are occurring simultaneously. Such a reaction is known as redox reactions. Such reactions are known as redox reactions, where RED stands for reduction and OX stands for oxidation. Okay. So, such reactions, whenever reduction and oxidation is occurring simultaneously, such reactions are known as redox reactions. And remember one thing very nicely, just make a star, just note it down in your notebook, that every displacement reaction is also an example of redox reaction. So here you can see this is an example of displacement reaction also. And every displacement reaction is also an example of redox reaction. Apart from that, I told you every displacement reaction is also an example of which type of reaction? Just think over it. That is exothermic reaction. If you're able to figure it out, that's very good. So every single displacement reaction is an example of exothermic reaction also. कॉपर सल्फेट को गुस्सा आएगा ना, कॉपर को हटा दिया, so that is an example of exothermic reaction also. And every displacement reaction is an example of redox reaction also. Very, very important thing. Fine. So this is one example of redox reaction. Whenever there is oxidation and reduction. What is oxidation? Adding of oxygen is oxidation, and removal of oxygen is reduction. Okay. In exams, if you are asked which of the reactants is undergoing oxidation, so that is iron that is undergoing oxidation. Which substance is getting reduced? Which substance is undergoing reduction? So it's copper sulfate that is undergoing reduction. Remember that, it's very, very important. It's copper sulfate that is undergoing reduction. Okay. Which is the oxidizing agent? So the one which is undergoing reduction is an oxidizing agent. So oxidizing agent is copper sulfate. And which one is reducing agent? The one which is undergoing oxidation is a reducing agent. So iron is a reducing agent. If you want, you can take a screenshot. I'll just shift to side. Okay. So what is undergoing oxidation? What is reduction? What is the oxidizing agent? Which one is a reducing agent? That all is there. Okay. Now coming to one more example of redox reaction. If I'm just raising this out. If zinc oxide is there and carbon is added to it, okay, then we get zinc and carbon monoxide will be formed. This is also an example of redox reaction, and this is also an example of displacement reaction. Carbon is more reactive than zinc, so it displaces the oxygen from zinc oxide. Okay, so zinc oxide, there is removal of oxygen. So I hope you can guess that this is reduction. And carbon is adding up oxygen. So there is oxidation of carbon to form carbon monoxide. There is oxidation process. Apart from that, since there is oxidation of carbon, means it is a reducing agent. जिसका oxidation होता है वो खुद reducing agent होता है, because it is helping zinc oxide to undergo reduction. So it is a reducing agent, and since zinc oxide is undergoing reduction, it itself is an oxidizing agent because it is helping carbon to get oxidized. So zinc oxide is a oxidizing agent. I hope you are clear with the concept. If you have any doubts related to any of the topics, please let me know in the comment section. I hope that is fine. Okay, I'll be telling you one more example of redox reactions. Manganese oxide. This is manganese dioxide, MnO2. Okay, manganese dioxide is combining with HCl to form manganese chloride, MnCl2, plus water is formed plus chlorine gas is formed. Okay. Manganese oxide combines with hydrochloric acid to form manganese chloride, water and chlorine gas is formed. Okay. Now, in this reaction, there is removal of first let us balance this equation. It's not balanced. Huh? So, here I have two oxygen atoms. Here I have just one. So, we should make it 2. But now when we make it 2, we have 4 hydrogen atoms here and just 1 here. So, let's make it 4 HCl. Then I'll be having hydrogen also balanced. Now, if we just calculate for manganese, that's same on both the sides. Chlorine, it's 4 this side and this side also. On right hand side also, it's 2 plus 2, that is 4. So, my reaction is balanced. Now, in this reaction, from manganese oxide, there is removal of oxygen, and so this is an example of reduction. Manganese oxide is undergoing reduction. But one more concept is there. Removal of hydrogen. I told you, addition of oxygen is oxidation. But one more concept is there, that is removal of hydrogen is also oxidation. Removal of hydrogen is also an example of oxidation. So, if oxygen is getting added up, that is oxidation. But if hydrogen is removed from something, that is also oxidation. So, here from HCl, hydrogen is removed and what is formed is chlorine gas. So, since hydrogen is removed, this is an oxidation. So, there is oxidation of hydrochloric acid to form chlorine gas, and there is reduction of manganese dioxide to form manganese chloride. Okay. So, these are the examples of redox reactions. Apart from that, in this case, which is the oxidizing agent and which is the reducing agent, so since there is reduction of manganese dioxide, so who is carrying out the reduction of manganese dioxide? That is HCl. So, it is a reducing agent. What is helping HCl to get oxidized? That is manganese dioxide. So, it is an oxidizing agent. Okay, I hope that is fine. One more way by which you can work out oxidation and reduction. So, what the two things we have learned up till now is addition of oxygen is oxidation and removal of hydrogen is also oxidation. Okay, but what if a compound is not having any oxygen, not even having any hydrogen, then could there be possibility of redox reaction still? Yes, there is a possibility of redox reactions then also. I'll let you know of some examples for that. But before that, how we can work out a reaction in which there is no oxygen or no hydrogen, still it's a redox reaction. How we can work out that we'll consider. Okay. But before that, let's consider one example that is having oxygen in it. For example, ferrous sulfate is there, or we'll take copper sulfate only, na? That is very much familiar to us. Okay, so iron combines with copper sulfate to form ferrous sulfate plus copper. Okay, this is an example of displacement reaction as well as exothermic reaction, as well as it's a redox reaction that you have seen. One more thing that you need to remember is the previous reaction when we worked out manganese dioxide reacting with HCl. That was an example of redox reaction, but that was not an example of displacement or double displacement reaction. Okay, so some reactions could be there that are redox but not an example of displacement reaction. but every displacement reaction will be an example of redox reaction. Okay, so every displacement reaction is an example of redox reaction also and exothermic reaction also. Okay, now in this reaction you all know that this is an example of redox reaction. So which one is getting oxidized and which one is getting reduced? Let's work it out again. Since removal oxygen is there, that is reduction. Since addition of oxygen is there here, so this is an oxidation process. Now what we are considering is not given in NCERT book, but this concept will help you to work out the reactions where there is no oxygen or hydrogen in the reaction, but still that is an example of redox reaction. This concept will be really important if you are preparing for some competitive exams, NSO or any competitive exam you are preparing. So such questions could be there. Okay, but this concept that we are considering now, that is not there in NCERT book. Now here copper sulfate, you know that sulfate is -2 and copper was +2. Copper is +2 and sulfate is -2. Okay, now if it is +2, then now here its copper is 0. Copper is having a charge of 0 because neutral atoms, when it is in the atomic form, when it's in the elemental form, that is not having any charge, neither positive nor negative. Whenever they form compounds, whenever they form molecules, compounds, then they get positive and negative charge. So in copper sulfate, copper was having +2 charge, but from copper sulfate undergoes reduction, it forms copper that is having 0 charge, that is not having any charge. Means this copper must have gained electrons because +2 and -2 electrons, it must have gained 2 electrons. That is why +2 and -2 will become 0. That is why it has become 0. So gaining of electrons is reduction. Okay, just remember gaining of electrons is reduction. Or how to remember that? Negativity gain karoge to reduction hoga hi sahi. Okay, so whenever you gain negativity, there is reduction, and so gaining of electrons is reduction. Okay, now similarly here iron was 0. Iron was not having any positive or negative charge, but here when we talk about ferrous sulfate, SO4 is -2 and iron is +2. So it has become +2. Okay, what would have it done to become +2? It must have lost 2 electrons. It would have given 2 electrons to someone so that it becomes positively charged. Okay, so losing of electrons is oxidation. Losing of electrons, iron was losing some electrons, na? So that it became +2. So losing of electrons is oxidation. So for oxidation we can write one more thing, that losing or removal of electrons is also oxidation. If you find this concept to be difficult for you, you can just forget about it. Just do all the questions based on the previous concept, that is addition of oxygen is oxidation. By that only you will be able to work out the questions given in your NCERT book. But if you are preparing for some competitive exams, if you want to know something extra, then this will help you out to work out the examples that is not having any oxygen in that. Then also you will be able to work it out. I'll tell you one example for that. Okay, so gaining of electrons is reduction and losing of electrons is oxidation. Okay, I'll just shift aside. If you want to take a screenshot, I hope that's not required even, but you can take. I'll let you know one example where there is no oxygen or there is no hydrogen, but still it's a redox reaction and you can work it out. For example, okay, copper chloride reacts with lead to form lead chloride plus copper. I told you, every displacement reaction is also an example of redox reaction. So this is also an example of redox reaction. But now, how to work it out? Okay, so how can I work out? Since copper is here having plus 2 charge and here copper is having 0 charge, means copper must have gained 2 electrons. Okay, so gaining of electrons is reduction, gaining of negativity is reduction, and lead is 0 here. The charge on lead is 0 here, and here it's plus 2 charge, means it must have lost 2 electrons and given it to chlorine. That is why it has gained positive charge, and that is why losing of electrons is oxidation. Losing of electrons is oxidation. Okay, I know I'm going quite deep in the topic, but that's useful for competitive exams. Okay, one more way we can work it out, making it very simple. If you're confused about electron gain and loss, still we can work it out without looking at electron gain and loss by one concept. Oxygen is negatively charged, you all know. Oxygen is -2. Chlorine is also negatively charged. Okay, so gaining of oxygen or gaining of any electronegative element is the oxidation. Gaining of any electronegative element is oxidation, and gaining of any removal of any electronegative element is reduction. So removal of oxygen, removal of chlorine, removal of iodine, bromine, fluorine, removal of any electronegative element is reduction, and gaining of oxygen, gaining of chlorine, gaining of bromine, iodine, fluorine, gaining of any electronegative element is oxidation. Okay, so chlorine is like a brother of oxygen, है ना, sister भी हो सकता है. So chlorine, oxygen, whenever you see them, just in the reaction, if you observe that instead of oxygen there is chlorine, so just remember that chlorine is a relative of oxygen because both are electronegative, both are non-metals, and that is why their behavior is similar. Okay, I hope I have not made the concept complex for you. If you are finding this part of the topic difficult, then just consider the oxygen, addition of oxygen is oxidation and removal of oxygen is reduction. Okay, so that's all about oxidation and reduction. Remember, addition of oxygen is oxidation, removal of hydrogen is also oxidation, removal of electrons is also oxidation, and the reverse is also true. Removal of oxygen is reduction, gaining of hydrogen is reduction, and adding of electrons, gaining of electrons is also reduction. The reverse is also true. Okay, and all such reactions, when there is simultaneously oxidation and reduction taking place, such reactions are known as redox reactions. Fine. Now, looking at examples of oxidation in daily life. In daily life also there is sometimes oxidation of substances around us that we are going to consider. Okay, oxidation in daily life, where it could happen. So oxidation in daily life could be of some materials around us, some metals, or it could be the oxidation of food items. So there could be oxidation of metals that we use in our daily life, or there could be oxidation of food items, especially containing the fats. Especially if the food items containing fats, there could be oxidation of that fats. And if there is oxidation of food items, that is known as rancidity. Food items often cause acidity, but in the fats of the food item, there occurs rancidity. We'll discuss that. And there is corrosion of metals. There is corrosion of metals. That is also part of oxidation of metals. Okay. So what happens? First, let's consider about corrosion. What is corrosion? Metals like iron, you must have heard about rusting. You have observed rusting. It makes the iron somewhat like this. So whenever you can see here that the iron is combining with oxygen and moisture present in the environment, and it's getting rusted. A browny layer is formed. You can even see some flakes are formed, and that damages the iron. That degrades the quality and the strength of this iron. This corrosion of iron is known as rusting, and rusting is an example of corrosion. Okay, so rusting is one form of corrosion in which iron is combining with oxygen and moisture present in the atmosphere. Do you know that if we remove oxygen or hydrogen, either of the two, then there will be no rusting. So if you just prevent the contact of moisture from iron, then there will be no rusting. So rusting requires both the things, oxygen as well as water. Fine. Now, not only iron, copper also gets corroded. You must have seen a greenish layer on the surface of copper, somewhat like this. And this layer is formed because of reaction of copper with carbon dioxide present in the atmosphere. And this is known as corrosion. So, this green layer formed over copper utensils is copper carbonate, and it's formed by the reaction of carbon dioxide with copper, leading to this green layer, and that is known as corrosion of copper. Apart from that, silver also turns black. That is known as corrosion of silver. And the silver, you can see it's getting black because of reaction of silver with sulfur present in the environment or even in the sweat. So our sweat also contains sulfur, and because of that only the silver gets corroded. Okay, so silver gets corroded by reaction of silver with sulfur, and that leads to corrosion. That's known as tarnishing of silver. Okay, so these are some examples of corrosion. We'll learn more about corrosion in chapter number 3, that is metals and non-metals. Now coming to rancidity. If you open a chips packet and you consume some of them and just leave it aside for some days and forget about it, that could rarely happen, no? So if you just forget about that chips packet after like a month or 2 months, if you just find your packet of chips and if you want to consume that chips, you will find that now it doesn't taste good because the fats present in the chips packet have undergone oxidation. So whenever there is oxidation of food, oxidation of fats present in the food items, that is known as rancidity. Oxidation of fats present in the food items, that is known as rancidity. Okay, and this rancidity will alter the taste and the smell of the food item. We often observe that with chips packets or with like a namkeen, or if you just fry something and keep it and store it, after sometimes if you open that, that might not taste good. That could be because of rancidity. Rancidity should not be confused with getting moist. If the chips packet is left open, especially in rainy season, that get moist, that is not rancidity. Okay, so I have often see students writing that if it gets moisture, it reacts with the moisture present in the atmosphere, and that is known as rancidity. So that is wrong. It doesn't react with the moisture. That is not called as rancidity. Okay, reacting with moisture is not rancidity. So now, how to prevent this rancidity? You can prevent rancidity by preventing the food item to come in contact with oxygen, because oxidation of fats is there. So if you're not allowing oxygen to come in contact with that, that will prevent rancidity. One way could be just storing your food items in airtight containers. If you store them in airtight containers, that will not be coming in contact with oxygen, and that could delay the rancidity. The second option that is done by the chips manufacturers, that is they flush the packet of chips with nitrogen gas and all the oxygen from the packet is removed and it's all flushed with nitrogen gas. So now what happens, since nitrogen is an inert gas, it is not going to react with food items, so that will prevent the rancidity, because now your food item is not coming in contact with oxygen. All the oxygen is removed, and after removal of the oxygen, what is filled in the packet is nitrogen. But as soon as you open the packet, now the food item is exposed to oxygen, so you have to consume it within a certain limit of time, otherwise it will get rancid. Okay, so what was corrosion? Corrosion is the reaction of metals with oxygen, moisture, carbon dioxide or acids that will lead to degradation of the quality of metals, that is known as corrosion. And what's rancidity? Oxidation of the food items, oxidation of the fats present in the food items is known as rancidity. Okay, so that's all for this video. We have completed all the topics given in your NCERT book. We have completed with the chapter. In the next video, we are going to discuss many equations, work out the balancing of the equations. Apart from that, we'll work out which with every reaction we will see which type of reaction is that. Apart from that, we'll consider some important questions as well, some previous years questions that are important for your exams. Okay, so that's all for this video. Good day everyone.